Okie dokie, let's go ahead and make a video here about square roots. Square roots are just a way of squaring, or undoing, I should say, squaring a number. The square root of a number is the inverse of squaring it. So if we know that 5 times 5 is the same thing as 5 squared, then 5 squared being 25, the square root of 25 would be 5. The square roots just sort of undo that. That symbol over the top of the 25 is called a radical. And the radical of, sometimes you'll call these radical expressions, the square root of the radical of 25 is 5. The number underneath the radical is the 25. And again, the reason that that works is that the square root of 25 is really saying that's the square root of 5 times 5, or the square root of 5 squared. And again, if radicals cancel squares, right? They cancel each other away, much like addition cancels subtraction, division cancels multiplication. Again, square roots or radicals cancel squaring a number. They don't cancel all exponents. That takes some other kinds of roots. But a square root cancels a 2 as an exponent, a squared exponent. You can't take the square root of a negative number. You won't get a real answer. Sometimes we call those undefined. A better way to do that, actually, I'm going to cross that off, is just to say that your answer is not real. It's not a real answer. Again, we won't talk a lot about non-real numbers right now, but just realize that, again, that number wouldn't be a real number. Because, again, we have to say what number times itself, right, would have given us the number underneath. And no number times itself, no real number times itself is going to give you a negative answer, right? Positive times positive is positive. Negative times negative is positive. So nothing would work to get us a negative number if we take it times itself. Now over here on the right are just some common square roots. So I just want to kind of walk you through. Again, these are definitely square roots that we should know about. And I'm going to kind of work my way backwards. The ones where I know the answer to it. Again, the square of what would give you 2? Well, remember, we need something where it's 2 times 2 then. So basically, this would have needed to be a 4. And again, along those same lines, if we work our way down the screen a little bit here, again, something times itself would have to give you, 4. Well, the square root of 4 times 4, the square root of 16 then, right, would be 4. Along those same lines, again, 6, it's going to be a 36. Or basically, whatever that number is squared, so 9, again, the square root of 81 would have been 9, right? Because 9 times 9 would have been 81. And the same thing, this would have been 12 times 12, or 12 squared underneath there. And again, that number, if you're familiar with it, is 144. And again, we've got a lot of other very fancy numbers up here, but again, you should definitely get to know a lot of these numbers. 20 squared, very simply, well, 2 squared would have been 4. And a couple of extra zeros, right? 10 times 10 is 100, so 20 squared would be 400, very simply. And then actually finding square roots, we got to think backwards a little bit. Well, what number times itself, right, would give you 0? Well, only 0, really. What number times itself? We already talked about this one. 25 would be 5. 10 times 10 is 100. And 15 times 15. 15 squared is 225. So the square root of 225 is 15. All right, there's just some common ones for you. Just a quick hint, if you've got a TI-30 calculator, or really most calculators set up in the same way, the easy way to find a square root on the calculator is just this second button, very simply up here in the upper left corner, because notice that x squared is its own button down here, but right above it, right, there's a square root symbol there. So basically, if you want to find the square root of a number, you're going to press second x squared, and it should give you a little radical symbol on the screen. You'll put your number inside, much like this 16. You'll press enter, and doodly doodly doo, you'll get your number, right? So there you go. So second x squared gets you the radical, and then put that number inside the radical. All right, speaking of some easy ones here, or some different ones, what if we started mixing in some negatives? So again, the square root of 625, if you aren't familiar, you could type that right into your calculator. You'll find out very quickly that's 25. Because, again, the square root of 25 times 25, or 25 squared, would have been 25, right? The square root of 9, as we mentioned on the previous screen, is just 3. But because there's a negative out in front, well, think order of operations. we're going to kind of think of that radical as a grouping symbol. I can find the square root of 9 and then put on the 3 afterwards. So that just very simply becomes -3. So if you see a negative, don't immediately rule things out. All you need to do is realize it's not underneath. So I can take the radical, I can take that root, and then put the negative on afterwards. Same thing goes for this symbol over here. It's technically what we call a plus or minus symbol. It means we're going to get two numbers, but first we start with that radical. The square root again of 144, as I mentioned before, is a 12. Only the plus or minus means technically we can just put plus or minus, but it means it's basically 12 or -12. You can get both positive and -12. So you could technically write that answer both ways, but for now you can just write it the easy way, plus or minus 12. That's what we call that symbol. And again, down here at the bottom, square root of 81 would be 9, but again, the square root of -81, you can't take a number times itself, right, and get -81, not a real number. So again, for this one, we're just going to say not real. Now, speaking of those ones, those were nice numbers because they all came out nice and whole, right? Or at least as integers, they came out to clean numbers. Irrational numbers are a type of number that has an infinite non-repeating decimal. It's the easiest way to remember it, an infinite non-repeating decimal. Any terminating decimal, any repeating decimal, remember, is going to be a rational number. But an infinite non-repeating decimal, such as the number pi down here on the bottom, most people are familiar with that one, that's an irrational number. And one kind of interesting fact, any square root of a number that's non-perfect, right? So not like the numbers we just found, square root of 4 being 2 or square root of 9 being 3. The square root of 2 over here, because that 2 is not a perfect square, right? It wasn't a number squared. It's going to give you an irrational number. Any non-perfect square will basically be irrational. So again, you have all your rationals, your terminating decimals, your repeating decimals, rationals containing all the integers, right? Those nice whole numbers with negatives, or whole numbers alone without negatives, right? All of those things are real, but they're also all rational numbers. The other sort of portion of the real numbers are the irrationals. Square root of 14, for instance, and then we put that negative on afterward. -3.74165, ... because it goes infinitely onward. There's no repeating pattern there. So one of the things we want to be able to do with square roots is classify them. The other trick is, because some of them don't come out clean, we might want to be able to approximate them. So let's start with the approximate ones up here on the top. The square root of 10 is not going to be a nice number. It's going to be an irrational number, right? It's going to fall in that irrational number category. But what I want to do is sort of estimate it. Just because it's not a real number doesn't mean I can't, or not, sorry, a rational number. It is real. Because it's not a rational number, I still want to be able to sort of estimate the number. And I know that the square root of 10 would sort of fall in between the square root of 9 and the square root of 16. 9 and 16, again, being perfect squares. And I also know that the square root of 9 is 3, and I know that the square root of 16 is 4. So those are sort of what we call consecutive integers, right? They're right in a row, which means if the square root of 10, right, is between the square root of 9 and the square root of 16, right? 10 falls right between those. Then the square root of 10 would have to fall between 3 and 4. 200, kind of the same idea. We could say falls between the square root of 196. If you remember from our previous list, that's 14, right? But it's also going to be slightly less than, well, we'll give you a hint. If that's 14, and that's really close to 200, I'm guessing 15 here would be our other good number, which you'd be right, because remember 15 squared is 225. So if they ask us to find two integers, right, no decimals, no negatives, that square root would fall in between. I don't really know the exact number, but I do know it would be 14 point something, right? It would be bigger than 14, less than 15. So that's kind of how we estimate between two numbers. Now, again, just to classify our numbers, we'd probably want to calculate them. Notice negative the square root of 121. Well, I know that's -11, which in my mind means, well, it's not a whole number because it's negative, but it's also not an infinite non-repeating decimal. So it's I think it's an integer, which would also mean it's technically a rational number. It's a real number. It would fall in those three categories. The square root of 84, though, again, that's going to fall between the square root of 81, right, which would have been 9, and the square root of 100, which would have been 10. So again, between 9 and 10, it's going to be 9 point something, which just means, again, it's an irrational number. Now remember, that still means it's real. It just means it's not it's not rational, and it can't be an integer or a whole number then. And then finally, again, the reason we really want to calculate these ahead of time is this one looks a little bit messy, but realize that's just 2.3 times the square root of 36. Well, the square root of 36 would be 6, right? So really, I think this is 13.8. If we pop that in our calculators, and feel free to pause the video and try that, I believe it's 13.8, which means it's a terminating decimal again. Again, whole number wouldn't have a decimal. The integers, well, if it's not a whole, also wouldn't have a decimal. Irrational numbers would have had an infinite non-repeating decimal, but I believe rational numbers were okay with decimals, and of course, real numbers were okay with decimals. So again, I hope that helps you classify a few different numbers. Again, we're familiar with rational numbers, terminating decimals, repeating decimals. Integers, again, those nice counting numbers with negatives and or without. And whole numbers, again, without the negatives, just the counting numbers, right? Positive and negative, positive counting numbers and 0. Irrational numbers are that new category. If it's not rational, if it's an infinite non-repeating decimal, then we would call it irrational. I hope that helps you with, again, square roots and irrational numbers. If you have any questions, make sure you talk to your teacher. Otherwise, have a great day.